Good afternoon, my name is Dal Williams. Today I'm going to be talking to you about my Insight data product, Recyclouts. With this project, I wanted to address the problem of recyclable waste ending up in landfills instead of being recycled into raw material. One of the major causes of this is either incorrect bins or dirty items being placed in these bins. Adding to this complexity, different curbside programs have different requirements. My target audience for this product is colleges, since they have well-defined guidelines and college students tend to be more eco-conscious. Picture this, you're a transfer student. You originally went to Penn State with 7 bins. Going to UTK and continuing to be a good citizen, you realize there are now 4 bins. Even worse, what goes into these bins differs. A particularly bad example is plastic bags, which are okay at Penn State, but can actually damage the machinery of UTK's recycling centers. One way to fix this is using a smart recycling bin that classifies your recycling for you. This proof of concept constitutes the computer vision component of that with university-dependent classification. Going on to the demo, after you select your university, in this case, UTK, you click the button to predict its class after holding up your item. CPU inference takes around 10 seconds with screen capture running in the background. Now that we're switching universities to Penn State, we can see that it correctly classifies plastic bags as plastic instead of trash, correctly classifies corrugated cardboard as trash, and likewise with metal. To get to this point, university guidelines were obtained from their respective websites. Major classes, or streams, were then divided into subcategories. Google Images was scraped with subcategories as queries. The scraped images were hand-validated, removing noisy or incorrect images. The file paths of the valid images were then stored in a SQLite file with the relevant stream and subcategory. This resulted in 17,000 images belonging to 65 subclasses. Due to class imbalances, the majority classes, paper in both cases, were undersampled, and image augmentation, rotation, shearing, and zoom were applied to increase the generalizability of this model. The model chosen was a pre-trained MobileNet v2 due to both its inference efficiency and its small footprint, enabling the possibility of edge computation. Both models achieved around 55% accuracy on the test set. It's important to note that in this application, a false positive, i.e. a dirty item placed in our recycling bin, will hurt far more than a false negative. Though predicting trash and paper worked well, performance issues were likely due to leakage. Looking at misclassified images, color and texture are a major factor in leakage. Notice the bright pink of the post-it and the carpet in the background of the can being interpreted as paper. Unsurprisingly, differentiating plastic bags from other plastic items remains a difficult problem. For a next version, gathering more data and more advanced pre-processing could aid in solving this issue. In conclusion, I developed a prototype model to allow recyclable segmentation on a university-by-university basis, aiming to increase recycling center efficiency and profitability. Once again, my name is Dal Williams. I hold chemistry degrees from UTK and Ole Miss. In my spare time, I spend it with my lovely wife and family, including the fur babies, and play board/video games. I thank you for your time.